Excellent. So let's get started. My name is Dave Ward. I run product and engineering for a portion of EC2 focusing on pricing services and specifically own Spot among a couple other areas like reserved instances. Today we have a really exciting presentation for you. We have two great speakers. The first is Miguel. He basically runs managed services for a really wonderful customer for us. They are doing a lot of really interesting things with load balancing, and their business is very focused on retail operations. And so Opteros has this very interesting use case that most people wouldn't necessarily think is a spottable use case. So it should be a really fascinating scenario for you guys to think about. He'll start off by going over the basics of what Spot is, and then really dig into their particular use case and how they leverage it. And then second up, we have Weston from Tapjoy. He's an engineer that really focuses on system management, and they leverage Spot for testing. And so they're using Jenkins and a plugin specifically for Spot that really leverages not only both time and money, and saving a substantial amount of money. So he'll dig into a lot of those use cases, and he was actually one of the folks sitting in the crowd for this session last year. And so we thought it was fitting to bring them up on stage and really kind of talk through their use case. At the very end, we're going to save about 5-10 minutes. We'll share Spotathon results. Spotathon is a coding contest specifically centering around Spot that we just got done running. And so we'll talk through the winners and kind of their use cases and some interesting elements to that. And then we'll move on to question and answer for the remaining couple of minutes. And so as you're thinking about this presentation, I think there's a couple really important things that I really want to make sure you all are thinking. First, what is Spot? Just as a quick overview, Spot allows you to use excess EC2 capacity so that you can not only accelerate the time to result, meaning accelerate your answers by getting more compute processing power and actually kind of scale horizontally to try to advance your answer sooner. But the second thing is it saves you a substantial amount of money, up to 92% off the on-demand price. So there's a lot of opportunity to really optimize your cost and really advance your results. So part of the reason why we titled it this way is what we're seeing in the industry is a huge compression in the innovation cycle. And so the questions that used to take a really sophisticated algorithm, now people are brute forcing. Now scenarios where they used to wait a month is compressed down into a couple hours, or even they used to spend 5 years doing can be compressed down into a couple hours. So as you're thinking through this, as you're reviewing the presentations, there's a couple of key things I want you to think about in the back of your head. The first is, how are these customers handling availability? So one of the trade-offs with Spot is that you may not be able to get it depending on your bid price. Since there's a dynamically priced market, basically you put in a bid price, anytime the spot price is below that bid price, you get an instance. So I want you to think about how they handle the possibility that they may never get those instances. The second thing is how they handle interruption. So the question is, how do they ensure reliability? How do they handle the case of those instances going away in the middle of their workload without any notice? And as you think through that, think through their architectures and what they're doing for that reliability. The third piece is bidding. And so one of the things that we see in the market today is that 98% of the bids are actually fairly rational, is one of the ways of saying it, where it's about 30%, it's about maybe 70% under the on-demand price. There's roughly around there. However, there's about 2% of bids where customers bid exceptionally high, upwards of dollars for instances that are only a couple of cents. And so one of the reasons, Weston's going to go actually into a lot of details into why the prices float there, but one of the things I want you to think about is just bidding high is not a way of managing interruption. Instead, you should be bidding based on what you're willing to pay. And so as you're reviewing the presentations, think through how they are kind of bidding for their instances. Another piece that we often hear is, well, what's the return on investment with this? How quickly can I integrate with Spot? And so both of the speakers today will be talking about how do I integrate, how's it actually worked, and it's actually surprisingly short, and so it's one of the things to kind of think through there. And the last is just how are they using a portfolio of pricing models? So how are they leveraging both reserved instances, on-demand, and Spot in order to really optimize how they leverage their portfolio. So again, we have a great group of speakers, and I'll turn it over to Miguel to kick us off.
Is pretty much focused on e-commerce. So our workloads have to do with e-commerce and getting basically retail sales. That's not something that is typically associated with Spot instances. So this is a use case that we wanted to bring forward. We've been on Amazon since 2009, so one of the earlier adopters. And as a point of focus, I put our aggregate managed revenues at 550 million, just to show that there's a significant amount of resources behind this. It's not like two reserved instances sitting making some money. So there's a significant amount of resources, and it allows us to invest the time to do some special things to be able to integrate Spot into our workloads. So when you think Spot and you listen to all of the talks, you usually hear about workloads that can be interrupted. Within the e-commerce world, you're probably talking about things like analytics, report generation, the kinds of things that are maybe batched overnight. That's not the use case we're going to be talking about. What we're talking about has to do with load balance services. So anything in either, for us it would be commerce, but in any kind of architecture where you would have a service that's load balanced. So things like web servers, you have tax calculators, store locators, things that are typically scaled up. You have a lot of instances supporting a lot of load. There we go. So typical e-commerce architecture, and quite frankly, is your pretty typical three-tiered architecture. Nothing special here. You'll see you have traffic coming in. You have some front-end load balancers. And then you have load balancers in the back end for services. So if you're a SOA architecture, you might have some services in there. It really depends on how fine-grained you are. So what we're talking about today are the load balance services, and how you take a load balance array and Spotify it. I think that term might be used, but we'll stick with it. So for us, we do e-commerce. SLAs are pretty high. People don't want their sites coming down. So we really have to minimize the risk while maximizing the savings. So if you have a service, let's take a tax calculation service. So you have an array, it's load balanced, it probably has some auto scaling. So what do you do with that? Well, the first strategy is to just break that up into two different arrays. Within Amazon, that's fairly simple. So you have two arrays now. You have one designated as on-demand, one designated as Spot. Same service, same load balancer, so everything is the same. You've just separated it into two different arrays. So in terms of the actual code, the actual service itself, you've made no changes, none whatsoever. So there's nothing special that you have to do to get this into a state where it can take advantage of Spots. So now you have your two arrays. They're sitting there waiting for workload. That's where it gets a little interesting. So the decision point there is you have a ratio between on-demand and Spot servers. And that's really the key to the savings. The higher your Spot, the more savings, clearly. The higher your on-demand, the less savings, the more stable, the less risky. So depending on the service, and not every service will have the same characteristics, you can decide whether you can have a higher ratio of Spot, get more savings, or if it's too risky a service, it needs to be stable, and you have a higher ratio of on-demand. For our loads, we tend to start with a 2-to-1 ratio of Spot to on-demand. We then put it in. We try and see what the service looks like, how it reacts, and look at real-time data to try and make the decisions instead of trying to keep it theoretical. So what are the problems with that? Why doesn't everyone do that? Well, it takes a little bit of work to keep everything up. Spots will terminate. It doesn't matter what you set your price to, even if you think, oh, I'm just going to set it to some fantastically high price. Not that that's a good thing to do, but that's no guarantee that your spots will not get terminated. So you have to plan for termination. It's inevitable. So what are the strategies there? Well, that's why you have an on-demand array. What you have to do is you have to make sure that, A, you plan for the entire spot array going away in one instant at the same time. Because depending on what zones you're in, and I'll get to that a little later, that can in fact happen and will probably happen. So you have to have a minimum number of on-demands available so that you can keep a degraded level of service while you then scale up your on-demand service. So there's a minimum capacity that you have to think about. There's scaling up that you need to think about. How fast can you scale up? What kinds of servers? What is that period of semi-degraded service? And is it acceptable? So those are the kinds of things that you need to be thinking about. And as a precaution on your on-demand, it would be a good idea to purchase reserved instances so that you do, in fact, have that capacity. If you're using an on-demand array as the safety net, you want to make sure that safety net is, in fact, there when you need it. So best practice there is to also purchase reserved instances for your array. There we go. So bid prices. That's really the main deciding factor on what your price will be for a spot server, and will also be a factor that determines whether your server will be available and whether it'll get terminated. So you have to spend a little bit of time thinking about that. So this graph that you see right here is something that you can get right out of the Amazon console. I specifically selected a C1 extra large, happens to be an instance size that we use. And so you can see the spot price history here. You know, you have some servers, I believe that might be 1A that goes up to $4 over there. So you can do some analysis on what is an appropriate bid price for you. Now, the graph is nice and all, but when you do more than just a little bit of analysis, you'll probably want to download all the data. You'll see an API call down in the bottom there. That will get you the actual data in raw form where you can do some more sophisticated analysis. All right, so what are the bid price considerations? For those of you that can see very well, you'll notice that I have a date range of 1 day. You don't want to be doing an analysis based on 1 day's worth of data. The reason I'm showing you a day is so that you can actually see some detail on the graph and it looks nice. So do not take this as the way to do your analysis. This is just for demonstration purposes. So this is, again, for the C1 extra large. And if you look at the on-demand price, you'll see that it's 58 cents, and it's right there where the green bar is. So the first thing you have to consider when you're talking about bid prices is what is your tolerance for interruption? And what is the % likelihood of interruption? So as you can see, if you set your bid price to the spot price, your bid price to the on-demand price, depending on which zone you happen to run your servers from, you'll get very different reactions. So if you happen to be on 1E, you might not be too happy. Your servers will be terminated quite often. In this graph, it would be half the time you would not have your server. If you happen to be on 1D, it would be perfectly acceptable. Your % likelihood of interruption would be effectively 0, right? So in terms of the risk of your servers going away versus the how important that service is. Your zone choice is important. Your bid price is important. So if you decide that you want to run your spots in multiple zones, which is the best practice, you definitely want to be doing that for multiple reasons. One reason is if you have multiple servers, you're in one zone, and the spot price goes above your bid price, literally all of your servers will disappear at one time. Probably not the best thing for a high SLA type of service. So what you want to do is have spots in multiple zones, try and get a bid price that is at a range that has an acceptable level of tolerance for interruptions, okay? So that's one consideration. The second consideration, if I can get my slide to change here, is if you happen to put a bid price that is above the on-demand price, you then have a period of time where your server will more than likely be running at a price above the on-demand price. So what do you do there? One, well, that might be perfectly acceptable for you. You might say that I'm willing to accept that little bit of higher price for the trade-off of not getting my service interrupted. That might be perfectly acceptable. It might not. If you set your bid price at some outrageously high price thinking, well, that'll be the end of it, I'm never going to have to shut my servers down, well, that could be a lot of money. You saw on that previous graph where you had $4 bid prices. I'll be showing you a graph later in the European zone that will probably make you laugh. But you can probably blow your entire savings for a couple of hours of servers that are above the on-demand price. So this is very key to any consideration of what your potential savings might be. So that is something that you have to consider. Now, you do know when there are API calls and other statistics that will let you know when this is happening. So you can take action on this data, and a little later I'll be showing you what we do about that. But that is, I wanted to point out that that is a consideration that you need to be looking into. By the way, there's an enormous amount of literature on spot pricing and how to do bid pricings and various strategies online on the Amazon site and other independent sites. This is very simplistic. I'm not saying that this is all you need to do to get the right price. Getting the right bid prices is very service specific, very use case specific, so you might need much more sophisticated analysis. So there's plenty of literature out there. I would encourage you to go look at that. This is the graph I had mentioned about the EU region. You'll notice that we're talking $20 an hour for servers that typically cost 58 cents. So it doesn't take a whole lot of $20 an hour. You have 100 servers, you run it at $20 an hour. You've pretty much, not only have you not done any savings, you're actually paying more, and you've done the exact opposite of what you need to do. So I put this graph in here to illustrate two things. One, sometimes the bid prices can go crazy. Two, it is very, very different based on region and zone. So if you're going to do analysis, do not just do analysis on one zone for one bid price and think that your servers will react in the exact same way across regions and across zones. And also a tip for people who have multiple accounts. You probably are already aware that zones are tagged differently on different accounts. So if you do an analysis on zone 1E on one account, it may not be 1E on the second account. So make sure you match accounts, and you make sure that you're talking about the same zones when you pick the bid prices. So this is sort of a theme that has been going on here at Amazon. Monitor, 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 and monitor some more. So especially if you have spot prices, especially if you have bid prices that are higher than on demand. You need to monitor your servers. You need to take action, especially when the prices go above. And you need to be paying attention to what's going on. When your spot servers get terminated, the servers themselves are actually aware that they are getting terminated. So if you have spot servers, for example, that are getting terminated, and as your backup plan, you're scaling up an on-demand array, well, if you have your spot servers notify, as opposed to just waiting for the capacity to disappear, you can save valuable minutes on the scale-up time. So you can do, there are various techniques that you can do to make things a little bit easier. You need to be taking proactive action to make sure that you are, in fact, getting the savings. There's you'll see in the very last call there, there are API calls where you can actually download your actual instance usage. So Amazon gives you all of the information of what your instances are actually doing and the various prices. So you don't have to just go on theory. You can put this in place, you can operate it, and then you can look at the data and see whether you're actually saving and where you can refine and how you can make changes. So there's a whole feedback loop that you can do here where you can put this into place very, very quickly. Just as an anecdote, when we finally decided that we were going to go sort of whole hog crazy with the spot, and we decided to start to change our arrays, we literally did it over a weekend. This is not something that you have to do in 6 months and plan it and eventually it'll come. You can do this over a weekend. It's as fast as being able to create a second array and plugging it into a load balancer. If it doesn't work out for you, you can take out that array and don't do it, right? So you can test these things very quickly. There's not really a big barrier to getting going with it. So I just gave you a whole bunch of extra work to do. You're already probably very busy. You're saying, well, why do I want to do this? Really, is it worth it? The answer is absolutely yes. Dave mentioned that you get somewhere, I have 86%. I think that percent might be higher now, in the 90s, where a spot price is 90% cheaper than an equivalent on demand. So a few slides ago, I mentioned that we start with a 2-to-1 on-demand to spot ratio. If you just do straight math on that, you'll see that the potential savings there is 43% immediately. And at Aptaros, with the combination of reserved instances and a pretty aggressive spot strategy, in the course of a month, as we converted to it, we've seen savings of pretty close to 50%. I believe it's like 48%. So think about that. You have, for really not a whole lot of extra work, you can save 48% on the entire Amazon bill just by going into some of these strategies. Now, you do have to pay attention. You need to understand what you're doing, and you need to be able to take proactive action. But is 48% savings worth it? Or if you take that 48%, you can invest it in a lot of other things. And so for us, in our scale, it was absolutely worth it, and it has been going very well for us. With that, I'm going to introduce Weston from Tapjoy.
Thank you. Nice job, bud. Hi there. So thank you, Miguel. Thank you, Dave. Really happy to be here. Actually, mildly happy to see an empty room because it means maybe not a lot of people are going to use our strategies and the spot prices are going to stay low. But maybe that's not so good for Dave, obviously. So kind of quickly, who am I? I'm an engineer, but I got turned into a DevOps junkie when I joined Tapjoy about 1.5 years ago. Right now, I've got a couple of areas of focus that my group have to work on. One of them is performance, how efficiently are our systems running. The other one, which is the big one that we're going to talk a little bit about today, is cost management and total reduction in our overall costs. I'm also interested in just general efficiency. Are we being efficient with the way that we're using our time? And I'm also an as-needed firefighter, as you could probably see from our flow dock last night when I was helping people at midnight East Coast time. So it happens. Oh, well, that was curious. All right, so what's Tapjoy's challenge? So Tapjoy's challenge is that we are a mobile ad network, a very large one at that. We have over 435 million monthly users that basically interact with our platform. It's absolutely gigantic, billions of requests per day. We've got a very diverse user base. I threw this one statistic up there: 54% male, 54% male, 46% female. But then there's also another bit in there where we're actually very international. So more of our traffic comes from outside the United States than inside the United States. So we're not only trying to basically serve people domestically, but all around the world. Billions of requests per day. And because of this massive growth, we're constantly iterating, we're constantly experimenting, and we're having to do this at really gigantic scale, which is a real big challenge. Anytime we make a small mistake, it is amplified to millions of people around the world instantly. And so we have to be very good about what we do on a constant basis. So the general idea that we basically have at Tapjoy is that we take the same principles that we have in production, which is we want to scale horizontally, and we want to be able to grow as best we can. And we think about that as we want to scale horizontally everywhere within our infrastructure. So what does that kind of look like? Well, as you are forming a company, step one is you develop this killer product, you hire a bunch of engineers. Step two, you expand the product as fast as you possibly can, you gain market share, you're growing horizontally, you're continuously iterating, building a better product, growing, refining, scaling. And then step number four, which everybody in here I'm sure is experiencing right now, just massive profit. We're all just making gobs of cash. And then you, of course, then reinvest that profit and build some more products. So that's what everybody sees on the outside. Oh, man, it's laggy. What everybody doesn't see is that engineering is all about a game of trade-offs. As you're going along that way, you're constantly basically making choices and trading off different choices in terms of, I'm going to go really fast, and I'm going to write a comment that says, I'm going to do this later, and then, of course, you never actually do it later, but you always like to think that you're going to. Testing and QA are almost the very first thing that you're going to lag behind on. You're probably going to start not necessarily keeping up with a good testing and QA environment. They tend to get a little ragged. And on top of that, as you're growing, building a really good quality test bed for engineers can get really hard. So, as you're thinking about this kind of stuff, be a little bit introspective and think about what are the bottlenecks in your own development lifecycle. How are you simulating production for your engineers so that way they're not testing in production like we're also prone to do? And ask yourself the question, who actually is watching your costs? Not the finance guy down the road who basically pays the Amazon bill at the end of the month, but in your engineering organization, who is actually caring about how much money you're spending and letting people know, hey, there's a better way to do it. There's a more efficient way to do it. So, spots. I like to call them the Dremel of Engineering. I really like that. If you don't know what a Dremel is basically this grand utility tool that can basically do everything, but at the same time, it can't do everything. It is not a hammer. It is not necessarily a screwdriver, although I guess it could be. So you have to use it appropriately. You have to use it intelligently. So what is the mindset required to use a spot instance? Well, Miguel was going over it a little bit earlier, and it was really good. And so I kind of divided it into two separate areas. So first and foremost, you really need to think about application level redundancy and fault tolerance for your system. So as we were talking about, you can lose a spot instance at any time. It can exceed your bid price, and it's going to go away. So what are you doing to engineer that redundancy in place? So Miguel was actually talking about the fact that they use on-demand instances to supplement their spot pricing. You can do that. That is definitely one of the things that you can do. But at the same time, they're also having to engineer that redundancy, right? How does that get taken out of their load balancers? How does the traffic get distributed when those instances go away? So one of the strategies is that you should spread yourself amongst many zones and potentially amongst many regions, right? That is something that we at Tapjoy do. We are actually operating in multiple regions. So what else do you need to do? Well, you need to identify areas of required persistence, but not necessarily preferred persistence. So in this case, we're talking about something like a database, right? So I'm going to spin up a QA environment. I'm going to use spots. I don't want that database to probably go away. So I'm going to probably keep that off tucked into a corner and have everybody share that particular instance and then surround it with a bunch of spot instances. And then the last bit is that you want to understand how are your neighbors utilizing that preferred instance type. So Miguel was showing those great graphs of people bidding $20 in the EU for a C1 extra large. To me, that's just insanity, and alarm bells are going off and you're face palming. And so I'm just going to stay away from the EU because I don't want to try and bid against people who are willing to spend $20 on a 58-cent instance. It's mildly insane. So the reason why I split this up into two different sections is that that top area, engineering redundancy, spreading yourself across many zones and regions, is stuff you should already be doing anyway, right? Not necessarily even with spots. These are general good engineering principles when you're operating in the cloud. Because you know what? Zone failures happen. They're a data center. Data centers have problems. These are things that happen as an engineer. And you always need to be thinking about, how am I redundant? How am I fault tolerant? What are my failure scenarios? How am I resilient against that? And so when you think about spots, you take the exact same principles that you're using for your regular production applications and you apply it to what you're using spots for. So what do we do with spots? Well, let's actually take a step back. So when you're doing kind of engineering at the scale that we're doing, it means that you have a lot of code pushes constantly. We do a deploy a day, if not more. We have a lot of pull requests. We're big Git users. And so every day, we could probably see easily 50 to 100 pull requests that are getting submitted to the system. And we have lots of automated tests that are getting run on a constant basis because we're trying to prevent general regressions in our application platform. So back before we started using spots, anytime we would have to run a full test suite to verify that a change was not going to break the build, it was taking about an hour because we were running this entire thing very serially. And so what does that do? Well, that really slows down the review process, especially when you're talking about a fairly minimal change that you should still definitely let your unit test run. But now you could get sign-off from an engineer and they say, all right, this change looks good to me, but I'm still waiting on those tests to finish. So we ended up with a lot of these, OK, I approve this message so long as the unit tests don't pass, in which case then I reject my approval and don't do that. So that was the scenario we kept landing ourselves in. Oh, it did it to me again. So what did we start to do? Well, we started to scale out our tests horizontally with spot instances, right? Perfect example of what to do. Thanks to actually an RIT senior project, they built this EC2 plugin that basically allows Jenkins to scale horizontally on spot instances. It's really fantastic. We use it every day at Tapjoy. One of the things that we do is we basically go wide during business hours and we scale back in the evenings. So in the morning, we'll basically scale out a bunch of Jenkins workers to basically be able to take in and digest all of the unit tests that need to get run for all of the pull requests that are getting submitted throughout our applications. The workers scale horizontally really well. The tests scale horizontally out over the workers. So basically what that means is that we're able to go extremely fast because every single test is basically independent of one another and they're being run in isolation. So that means we can go out across many different boxes and run on many different workers. And the great thing about the plugin is that Jenkins is actually very smart about the termination. And let's say a unit test terminates halfway through, and Jenkins doesn't go, oh, the build failed. No, what it'll do is it'll suck that back up, go, OK, I need to retry it, and it's going to send it off to a different worker that potentially didn't get terminated. So what else do we do? Well, we benchmark a lot with spot instances. Last night, in fact, I was benchmarking C3, the new C3 instance type on spot instances. I wanted to see how fast our new React cluster was going to go when I migrated off to C3s. What else do we do? Well, we benchmark a lot of Hadoop stuff with spot instances. You've probably gone to a bunch of EMR talks where people are scaling that stuff out. We also do this as well internally. We basically will go as wide as we possibly can. So what does this mean? Why do you care about using spot instances? Well, A, they're cheap, but it also allows you to actually simulate what it's going to look like in production. So when you're talking about a system R scale, where you're talking about hundreds of thousands of IOPS per minute in a small system, and potentially hundreds of thousands of IOPS per second in a really large system, it really can become a challenge to actually predict how your system is going to scale at these really large values. So you actually do want to scale out basically a simulated production environment that you're hammering with real simulated traffic to understand, where am I going to fall over? How am I going to fall over? Am I going to fall over because I open up too many file handles? Am I going to fall over because I've got basically network congestion that's going on? Spots are really great for helping you determine how am I going to actually perform at real scale. It's not going to change on me, is it? Oh, there it goes. OK, so the cool thing that we do, and I actually have 3 Tapjoy engineers who have either worked on the project or use it on a daily basis, but it's called Tap in a Box. So what did we do? Well, we built Tapjoy production on Spot instances. So it was born out of this Tapjoy hackathon that we basically run once a quarter. And the idea is that we want to produce engineering growth and creativity, and we want people to be able to experiment with different ideas that they have, whether it's working on an idea like Tap in a Box, or I think we had a keg flow meter that people built, so that way we could determine when our kegs are going to run out of beer. So when we were talking about building this, we kind of posed the question to ourselves: what if spinning up a QA environment for an engineer was as simple as launching an app server on Heroku? Now, for us, we don't use Heroku because we need to go really, really massive. But Heroku has a lot of nice properties in the sense of how easy it is to actually get up and running. So what we really wanted to know was, could we actually encapsulate all of Tapjoy production using Spot instances? So basically create a simulated environment that really actually behaved, operated, and performed like production. Was as simple as basically pushing a button and you would get a server. And then not only that, but we were able to save money through improved quality because we weren't breaking stuff as frequently. And it was also really low to operate. So more or less close to free, especially when you're talking about spots. So we really wanted an end-to-end product, no mocks, no stubs. We wanted it to be just like production. So what did we do? Well, we built a fully automated build and deployment process tied to a developer's GitHub account. So basically, anytime they pushed code up to their GitHub account, they were able to actually then automatically deploy it to their own personal Tap in a Box server. There's a really simple web interface for creating, managing, and editing instances. You can put in custom environment variables. You can basically say, I want to test this branch. I want to test that branch. It's really great for collaborating very quickly with product managers, our remote QA teams, partner testing, allowing people to actually see what it's going to look like when we actually launch this in production. And what else? Well, it's fully run on Spots, well, except for the dashboard, which we were talking about, required persistence. We didn't want our dashboard to just suddenly drop away because Spots were too expensive. But all of our Tap in a Box servers run on top of Spot instances. So here's a nice little screen cap of basically what our deploy board looks like. And so basically you can see that we've got a bunch of different engineers at Tapjoy that are using it. Some people actually have more than one Tap in a Box up because they may be running multiple separate QA environments because they have potentially our offsite testing team testing one particular service. They may be doing something more long-lived where they're actually testing out a more long-lived feature set. You can actually see that we have Tap in a Box servers that, in this case, have been up for over 5 days. I think there was a period of time where we had them up and running for well over 45 days before they actually got terminated by the spot price. And we are not nearly as aggressive as Miguel is with regards to our spot pricing. We actually bid very, very minimally above the on-demand price, and we always basically pay well below, like in the 85% off for the actual spot price over an aggregated month cycle. So here's what it kind of looks like when you're actually building up a server. We're able to specify, here's the specific type of project that I want to test, right? So we're basically, we're attempting to be more and more of an SOA shop and build out our projects in kind of isolated test beds. And so each of these projects need to be able to get launched in this Tap in a Box environment. Developers can set their own subdomain. We use this really cool thing called slugs to basically deploy our code. It's really cool, so you can specify what the tag is, and then a bunch of other interesting little features. So how did we actually build Tap in a Box? Well, we're a Ruby shop, so we used Ruby on Rails to build out the deploy board and do a couple of other things. We obviously use the AWS CLI because all the stuff is automated. A developer doesn't actually have to go in and boot anything up. It just happens. So we interact with that over the CLI. We're a big chef shop. Basically, every single server that we have running out there, whether it's in QA or production, is always chefed. And that's really great because I can automatically bring up a box, and it's pre-configured, and it just works. We obviously use EC2 Spot instances. One of the things that I was saying earlier is that we are not only zone, but also region agnostic. So when you're talking about QA environments or testing environments, I don't really care if my servers are running down in Sao Paulo. That's fine, right? I'll let them run in Ireland if the spot price is cheap enough. I'll let them run in Northern California or Oregon. I'll let them run wherever. It doesn't really matter to me. So we're always out looking for basically the optimal place to run our instances that's going to be the most stable, but also basically be the cheapest for us to run. The other thing that we're using is this project called FPM. I think it's called Effing Package Manager or something like that. I can't remember what it actually stands for. And this is a really cool project. We've been using slugs both in a couple of different projects for a while, and now we're using it basically in our entire production system. It's really fantastic. It gives you this really condensed, isolated ability to deploy code out to any server that you want and do it really rapidly. And it's very predictable about how it works. So kind of a couple of pointers and lessons learned that we had from interacting with spots. One of the things is that spots can take a while to provision. And it's a very different sort of workflow model than a regular on-demand. When I go and I ask for a C1 extra large and R1E, it usually happens pretty much within maybe a minute or so. The spot instances, even if the bid price is sufficient and there's not a lot of contention in the region, it can still take a little bit longer for that stuff to roll around. Because you're basically saying, I am willing to pay this, and so please spin up an instance as soon as this becomes available. As opposed to when you're using like a tool like IronFan, for example, you're basically saying, all right, boot up this on-demand instance and now wait for it to actually come online. So you basically have to think about maybe tooling slightly differently to basically be able to handle this different type of workflow. One of the very important things that we've talked about now multiple times is you really need to find those quiet zones and regions based on your workload. So what time of day am I running my instances? What am I running on those? Do I care if they get terminated? Maybe I don't care that people are spending $20 on their spots because I don't care if my stuff gets turned off. You need to basically ask those questions for yourself. And then sometimes you also have to say, well, pricing is going to take a backseat to reliability. I'm willing to maybe pay a little bit more to be a bit more reliable. Or maybe I'm willing to use a different instance type. So normally I wouldn't run on an M2 extra large, but it turns out that they're a lot less contentious than an M2 extra large, and so the actual pricing may be cheaper for a better and bigger instance. You have to ask those questions as you're building out your instances. So one of the things that you need to do is you need to guard against termination with adequate pricing. Don't put in 15 cents for something that has a 12-cent bid price because it's probably going to get terminated very quickly. But also at the same time, don't try and prevent it, right? Allow failures to happen. Engineer around the failures. Understand, how can I automate my system? How can I have it so it automatically comes back up and it's as though nothing ever had changed? Because the prices are actually going to eventually come down at some point in time. Now, they may skyrocket back up an hour later, but they will fall. They usually always fall. And then at the same time, pick the right tool for the job. Spot instances are a Dremel, they're not a hammer. Right? They can be used for a lot of different things, whether it's in your production environments like Miguel or in the QA environments like us. You really need to understand, what am I trying to accomplish, and then does Spot make sense for me? Now for us, Spot makes sense for us in almost all of our cases. We're a little bit more cautious about using it in kind of our production web servers because we don't want those to obviously just disappear on us. But we do use it in our production environments, especially for like queue processing and things like that. Things where if we do have a slight delay because we buffer up a little bit because we're using SQS and it's automatically buffering up basically to infinity for us, then we don't care if we have to go and then dynamically spin up some on-demand instances to drain the queue while we wait for the spot price to come down. So there's a lot of different ways that you can utilize spot instances both in QA and production. Ooh. So, a couple of parting thoughts. I'm preachy. So where do spots fit for everybody? I think that they actually fit no matter whether you're a really large business or really small business. I don't think it matters if you're an engineering organization of 3 people or you are Amazon and you guys are an engineering organization of well over 1,000 people, because you know what? Things cost money, right? Spot instances are a great way for you to save money and reinvest that in things that are much more useful for you, like other engineers. Why in the world would I want to pay $20 an hour for an instance, like some people were doing in the EU, when I can be paying 10, 15 cents for an instance that normally will cost me 60 cents? I can reinvest all of those savings into things that matter. Not dumb servers that are just kind of operating. I can invest them in people who are going to build me new products, who are going to be kind of the creativity and the people who are actually going to produce things for you. So it doesn't matter if you're a small business and you're 2 or 3 people, or you're a 1,000-person company. You should be understanding, how can I save money and how can I reinvest that in the things that got me there? And then on top of that, never grow out the techniques that you use to actually get to that high scale point, right? If you're an engineering team of 3, you're going to be really agile and you're going to be working as rapidly as you possibly can because you're trying to build and iterate on products. When you get up to that 1,000-person engineering organization, stay agile. Keep using the same techniques that you were using before. Keep using spot instances. Just because you're worth, you're making millions of dollars a day doesn't mean that saving, $100,000 a day doesn't matter, right? Those sorts of things always matter, even when you're a really large company. Always use the right tool for the job. Don't use a spot where an on-demand instance would do. Don't use an on-demand instance where you should be buying a reservation, right? Because reservations are another great way to save money. So I put at the bottom, don't waste money. It doesn't make sense. Why in the world would you just want to blow cash on servers when you could be reinvesting that in the things that are actually going to make you money over the aggregate? So I drew this kind of little picture because this is kind of how I actually see things in my head. We talked about, in the middle, you're in this land of profit and everybody's happy and everything's working really well. So on the left-hand side, you're in that land of startups, right? You're quickly iterating on your products, you're learning from your mistakes, you're envisioning your product on a constant basis, you're building a gigantic customer base. For startups, this is basically 99% for engineering organizations in general, this is basically 99% of us, right? Most of us are always in this kind of stage. Even when you're in like that 50, 40-person team, you're still basically, a startup. And so what are you using when you're a startup like that? Well, you're using spots, you're using on-demands, you're using reservations, you're using some third-party services. And then as you continue to grow and you understand how your business is progressing, you then start to invest in one-year reservations because I actually understand, this is what my market is going to look like over the next year. I can actually project this out at this point. And I'm making a lot of money, and that's why I'm super profitable. And then there's this kind of weird gray space that everybody seems to kind of languish in, which is this kind of wasteland of growth. And you're just, constantly growing, but you're not really ever thinking back to what actually got you there. And so what ends up happening? Well, I know what my business looks like, so I'm going to buy some 3-year reservations. That's great way to save money. But then what am I going to do? Well, I'm going to start to maybe buy some hardware because, why not? I'm really big now. I'm going to go, rent out some colo space. That's going to be great. I'm going to get Direct Connect because Direct Connect is really cool. And I'm going to go build my own private cloud because, why not? But you know what? All that stuff is really, really hard. Take it from me. I've had to do it, and it is a real pain in the butt. And it's not necessarily a pain in the butt because the vendors that you're working with are hard to work with. No, what it really comes down to is that it's just a lot of work to build out all that infrastructure. And what then a lot of people do is they get over there and they've built all this stuff out and they've got all these predictable costs and they've got out this predictable business and they're sort of just languishing in this other space. And they forgot about all the things on the left-hand side that actually got them to where they were. They forgot about where they were when they were just a small startup. They forget about how can I use a reservation market to maybe save myself some money while I'm working on this project for 6 months and trying to see maybe this is good, maybe this is bad, but I want to be able to drop it on the floor if I don't need it. Using spot instances. Why aren't you using that for all of your QA environments as you're building these things out? At Tapjoy, we are on a daily basis using well over 150 spot instances. And that's saving us tens of thousands of hundreds of thousands of dollars on a yearly basis. So for a company our size, if you can save that kind of money, if you're really large, why wouldn't you be doing that? Because you could potentially save yourself millions of dollars over the course of the year. So I wanted to kind of give you that parting thought. I think we're going to bring Dave back up, and he's going to announce the Spotathon winners. Yeah. Oh, I'm sorry. Actually, real quick before. No, Dave, you can come up here. It's fine. I'll give Dave kudos too. No, I wanted to give kudos to our automation team: John Russell, Chris Gerber, Jay Lowe, Adam Bell, and I actually have Hugh Berrigan in the audience. They're the guys who built out a lot of this stuff. I'm just the mouthpiece that just likes to talk about it. So, excellent. Thank you guys.
Perfect. Yeah. Thanks so much. Excellent. So hopefully you guys had a chance to learn quite a bit today. At the very beginning, I said, please make sure you think about a couple of different points. One was really the availability of the instances. And so hopefully you were able to see from both Weston and Miguel's speeches that you really have the opportunity to do multiple pricing models and that they really do have scenarios where if those instances go away entirely, they have the opportunity to run at least the workload that makes things continue to run at a certain throughput by running both on-demand and RI. In terms of interruption, you can see that a lot of their workloads actually have fault tolerance to them, or they're willing to make that trade-off of availability to actually having those instances around. From a bidding perspective, a couple of things just in terms of the things they thought through. One, every use case has a different bid price that's really important for them. Two, you pay the spot price, not your bid price. And that really does translate to a significant amount of savings. Each one of them actually has saved, I think 50% is what Miguel was saying, maybe 48%. And you could probably push Weston to try to get a savings number out of him. In terms of other areas, though, I think that it's really important that both of them mentioned that the integration time was actually really low. So in Weston's project, that was a hackathon project where literally I think they spent 3 days. Was that?
3 days for the prototype, and then now they all boot in less than 10 minutes.
Yeah, so 3 days for the prototype, and now they boot within 10 minutes. So a significant amount of really, really interesting things that you can do with leveraging Spot. So with all that said, hopefully that will either entice you or help you perceive Spot in a different way, that there are multiple use cases beyond just the 1.21 petaflop cycle run that was just announced, which is definitely really, really cool. So with that said, let's turn it over to the Spotathon results. So this year, we actually had a really amazing Spotathon. One of the things that we've seen between this last year and this year is that the complexity of submissions has actually increased significantly. So now people are actually really leveraging new bidding strategies. They're leveraging both reserved and on-demand and spot all together as a portfolio of submissions. So a lot of really interesting things. And there was actually a lot, really, really tight competition. So we had 6 judges this year, ranging from people all around Amazon. And there was actually a really close tie towards the top. So I'm going to start with 2 honorable mentions. These will be listed on our blog at the very end, or when we get it up there, probably will be launched next week. The first is Viscale and Flux 7 for their joint entry of a video processing submission. So they have this really cool machine learning algorithm that identifies how to launch Spot at the lowest possible instance, at the lowest possible price. So it was a really creative way of analyzing the price history and really coming up with the ideal place to launch and when to launch it. The second honorable mention, it goes to Artimotion. If you guys want to stand up if you're here, I know that Flux 7 is here. So, excellent. So Artimotion is basically, it does rendering of 3D films. And they actually have a really cool demo on their website. So hopefully when we get the blog posted, everyone can go out there and check it out. Very cool submission in terms of how they leverage Spot, just in terms of video rendering. So in terms of the runner-up, we have a $3,000 credit for them, which we'll take care of, obviously, offline. Their name is Big Web by Big Data Corporation. So the problem that they were going out to try to solve was how many websites are in Brazil and what are some of the trends that are going on with the website. They basically collect over 3,000 data points over 4 million websites, and this is done every single week. And so the data that they provide to their customer really shows kind of that progression over time. So they use Spot for their worker nodes as they're going out there and mining the web and dynamically adjust their bid to really try to focus on the cost per run. So they tend to need around 48,000 instance hours per run. And when they were originally scoping out the project, they were expecting to run pretty much a run over 20 days. And so they would take a snapshot, then run the next, run the next. They actually were able to get that down to 2 days. So a significant amount of time savings. And the other really interesting thing is that they saved over 73% over the on-demand price by leveraging this strategy. So the title, just to kind of go back to why are Spots interesting? And part of it comes down to being able to save money. But the other part is it really transforms how you're able to kind of innovate. And so now the trends that they're looking at aren't just the statistical trends of 7 days, 7-day block, run once every 20 days. Instead, it's every 2 days they can now get a new snapshot. And the statistical trends that they can come up with are extremely interesting. The last entry is for the $5,000 grand prize, goes to Dr. Brown and Dr. Beavis at Ohio State. Now, I'm a Michigan person, so it's kind of bittersweet for me, but they actually had a really interesting earth science and climate change set of research that they're doing that goes over 300 GPS satellites or GPS networks. And they have over millions of data files that go over 20 years of data. And so typically with the cluster that they have in-house, it would take them 7 to 8 weeks per run. And it would take over, on a single computer, it would probably take about 17 years to process. So using a combination of Spot, S3, SQS, they used thousands of instances to actually go through their process, and they finished the job actually in hours for about an 80% savings. I believe this one was mentioned on CNET, is that right? Wired, sorry. So it's a great article out there that talks about them and really accelerates the time to science. And so this is another great example of how we can compress that time to result. You know, and in the rest of the runs too, it really enables, you know, dev test. How do we actually do more testing? How do we really empower engineers to transform how they do engineering? And obviously on the retail side too, it's how do we enable better cost savings so we can provide better SLAs by kind of accelerating that time to result. So as you're thinking about things and potentially leveraging this in your architecture, these are some great examples. Definitely great job on all the submissions. And I would encourage you to think about how you can change the paradigm and flip what you're doing on its head. So rather than thinking about needing a small number of instances over a long period of time, what if you could get those results really fast or really cheaply? What things haven't you been able to do just because it's been cost prohibitive? And how can you apply Spot instances to really transform your architecture?